All right, good morning, everybody. My name is Mike Schuster. I'll be talking for the next 20 minutes, and my talk is about how can AI from tech be used in finance. So my own history a little bit, I have a background in tech. I worked for a long time in different companies in research and development, mostly on neural networks, on machine learning approaches, on complex systems, with applications for speech recognition, for translation, for recommendation systems, language models. These days it's a big topic, but language models have been around for decades. It's just that recently they've become like a little bit of a bigger thing. So I entered finance at 2 Sigma in 2018. If you don't know what 2 Sigma is one relatively large investment company, but small in finance. It's about 2,000 people. We do a lot of things. It's a financial services company, what we call us, but the investment opportunities are probably the largest, and we'd also do real estate and venture capital, private equity, and some other things. Anyway, I came in 2018 there and started building an AI team. Of course, 2 Sigma has done a lot of machine learning and AI for quite a while, but they wanted to do more, wanted to do it more like in tech and to solve financial problems, and that's what I came for. So for the agenda, what happened in tech? I'm going to talk about that a little bit because many people in finance are not familiar what actually happened in tech. You just see it on your phone or you use it every day, but you're not really familiar what happened when. What are some of the differences between tech and financial research? Because I've worked in both, it's interesting to see the differences. And maybe what can we learn from each other? So I have 2 slides with trends of search terms, and this is from 2004 to 2023. I wish I could have gone back longer, but this is the only data I could find. So if you look at this and you start with the yellow line, this is neural networks, and you see in 2004 there were a lot of searches, this is from Google, right, for neural networks, and then it somehow died down, and recently it has been a little bit more. There's a peak somewhere, I don't know exactly why, but so this is about neural networks, which are used a lot in tech and in finance recently as well. So now deep learning. Deep learning is something that basically as a word didn't exist until like 2012 or so when it was developed. It just came up out of, I believe, the University of Toronto around Hinton, because they called their things deep learning. It was the same as neural networks. But, and recently, it's actually a bigger term than neural networks. So similar for machine learning, the red curve, machine learning has, recently, since 2017, it has become more and more prominent. And then the last topic is artificial intelligence. Well, artificial intelligence, you see in the past, search for it a lot, and especially recently, in the last few months, it has become a bigger topic again. So now, if you add 2 more terms to this, AI, just as a term, not artificial intelligence, and ChatGPT. So here you see that they completely dwarf all terms, but what is important to remember is just how much language changes and how much people, basically a hype is built with certain words that come up, while all of these things are neural networks. Okay, so what happened in tech? There were actually big jumps in system quality in a whole bunch of fields, and I worked personally on a bunch of them. So in 2010, I would say there was image recognition, when companies like Google and Facebook and others, they started really recognizing anything in images. And this happened because neural networks were introduced. In roughly 2011 to 2012 or so, this happened in speech recognition. Today, you have it on your phone, you think it's normal. In 2006, that didn't exist, right? In 2016, there was machine translation, which suddenly made this big jump in quality. Suddenly, you could read Korean newspapers or Japanese newspapers, which you couldn't do before. And this also was because neural networks were introduced. In 2017, maybe some of you have heard that in games, DeepMind made a big jump here with AlphaGo. So the first time a computer actually beat the world champion in Go. Then there was protein folding just a few years ago, a big thing which wasn't possible before. It's called AlphaFold. And then very recently, large language models, what came out from OpenAI was ChatGPT. Large language models have been used and researched in many large tech companies for a long time, but OpenAI came out with this one, and that one stuck. A lot of people today use this. So one thing that is interesting is almost every these big jumps in system quality happened, the arguments that I've heard is, oh, this is never going to work, this is too complicated, not much improvement is possible. And in every single case, it was possible. And this is something that basically we want to do in finance as well. So, but the question is, how did these breakthroughs happen? And I think it's relatively straightforward, right? Lots more people started working on the research. What used to be 20 people worldwide is now, I don't know how many thousands in research. And it was always in universities, but today actually mostly in large tech companies. Some people had enough freedom to question the status quo, which is important because if you want to make a big jump, you need to be able to criticize what was there before. And you need to have at least some people who can do this. So then compute. Of course, compute became, 100, 1,000 times faster and cheaper. And cloud compute became much easier to use. I mean, as an example, Google has had this internally for a long time, but now everybody can go on their laptop and connect to some cloud, pay some money, and use actually a lot of computers at once. Finally, collaboration. So research means that people and engineers started working together more within companies, but also across companies. The ideas were shared via papers. Code was shared via open source. And these are things that are necessary to do this large-scale research. So if we talk about AI research today, obviously it requires significant financial and time commitments. So again, people, creative experts, mostly from the STEM field, are hard to find and expensive. Collaboration and communication is important. You can't just sit only by yourself at your computer and do something. You need to talk to your colleagues as well. And it's often actually a challenge to have a team really work well together. Many of you who are maybe managing teams know this well, I think. Technology. So in technology, of course, you have to use the latest tools, right? Complex systems and tools, which means, in our case, TensorFlow, PyTorch, I don't know, there's many, many more of these. These are just some examples. The compute with multiple GPUs and TPUs in the cloud, you have to have a more modern development environment with code reviews and unit tests and so on, and the culture to actually be able to use things like that. So finally, the research process. I'm going to talk a little bit more about this on another slide too, but vision is key. But finding the meaning and goals is part of the process too. So if something is always clear what to do, it's not really research. So there is a lot of patience you need as a manager, and you also need to expect failure, which is something that is in finance often a little bit harder to get through than maybe in other fields. So AI research in finance, and now I talk a little bit about what we work on. There are lots of interesting scientific problems to work on. For example, try neural networks. If you haven't tried them before, try them out. You can always make your training faster. You can use bigger models, right? That is often good because it allows for faster research. You can make use of terabytes of data, which we do. Sounds easy, but actually terabytes of data is quite a bit, and you do anything with this. Even copying it from one place to another place is a big project, or not a big project, but anyway, it's harder if you have a lot of data. So there are lots of engineering improvements possible, and these are more the things that we do. How can we help the company within the next year? But then for longer term research, we say, what will happen in the next 3 to 5 years? And there are things, and this is just in our case, we work on some reinforcement learning approaches. We work on integrated end-to-end approaches, just like on the text slide that I showed you before. We recently started using, obviously, large language models, just like everybody else. And there's probably more that we could do, but there's only a limited number of people and a limited number of things we can do. So some of the differences of research in tech and finance, people ask me all the time, so what is the biggest difference between you came from Google, now you work at this smaller company, and finance companies have just magnitudes fewer people. So also in research. At Google, this is just an example because I worked there, there are thousands. We have maybe a total of 200, right? Maybe actually less, fewer people. So, and that makes a big difference because you have to do a lot of stuff yourself, right? It's just a smaller company. I noted that finance companies generally employ more statisticians because maybe historically, also because the problems are a little bit more tailored towards statistics than to engineering, but still lots of engineers are needed. Data. Data is much more limited in finance. There is, of course, a lot of data, lots of vendors that sell you data, but there's only one day at a time. And that is one thing that is, I have on a later slide as well. If you want to predict the daily stock price of Apple, you have to wait for quite a long time to get enough data to really test whether your approach works or not. So another big difference is privacy versus regulation. In tech, many processes, data access, etc., are really driven by user privacy concerns. And in finance, at least from what I know, it's such a regulated industry. Many processes, data access are driven by regulation, by the SEC, by CFTC and other regulators, which is just a different thing to get used to. Secrecy is, of course, exists everywhere, right? In tech and in finance, but it's maybe a little bit more prevalent in finance just because the company is smaller. Some things are easier to copy. And to protect the IP of the company, there is, I feel, sometimes a little bit more secrecy. So this is about the research process. How do we decide what to work on? There's this great quote, "When the facts change, I change my mind. What do you do, sir?" Right? This is from Keynes. Actually, I looked it up. It's apparently from Samuelson, another great economist. But this is an important thing to keep in mind, right? You have to basically look at things all the time, how they change, and make corrections to your path and to keep being on the right path. So what does that mean for us? It means constant sourcing of ideas from people, from papers, from conferences, etc. Constant really re-evaluation of the motivations. Why are we doing these things? Often you find that there are people in the company who think they know what to do, and maybe it's actually correct, but often it's very hard to do. I'm sure you have people who tell you, hey, we should just do this and it would all work. Okay, then let that person maybe have some more responsibility and let him do it or her do it. And often it's very hard to get things done. Also allows some failure. I've said this before. When I first came to Two Sigma, in people that I worked with, they were very reluctant to fail. And that's a big danger, right? If you never fail, you're definitely not taking enough risk in your work. So some loose rules that we go by, we say if the original motivation for the project still applies, one, if we're still making progress, and if we have nothing better to do, no better project to work on, then we will just keep working on the project. And that has worked actually quite well, right? Of course, it's not some random research we do. We strive for really maximum practical impact in the company. So I have a few slides about misconception about finance because people ask me this stuff a lot. And one thing I always hear is, oh, I want to work in finance because it's so easy to measure results. And this is one thing that I always tell people, it's probably more the opposite. It's really hard to measure results, right? The reason is just the underlying problem. In tech, it's relatively easy to collect large test sets, let's say in speech recognition or in translation. You just ask more people and get a large test set, and you can statistically prove that your new thing works, right? In finance, the data is so scarce, and there's only one day at a time, so you have to wait. And there is things like COVID, just in the last few years, right? There was COVID, there was a retail crisis, there was a Ukraine war, and some other things that really made finance complicated. Same with the testing. So for some people say, okay, why don't you run a live A/B test? That is really only possible in some rare occasions. Usually it just takes too much time and it is too complicated. Simulations are also tricky. So these are just some of the things that is maybe a small misconception. So another thing is, a lot of people tell me, oh, everything is about time series modeling. That's not really true most of the time. Of course, there is generally a lot of time series modeling, but you look at smaller problems that often have nothing to do with time series modeling. So what is important for you as a candidate or as somebody who wants to work there is CS engineering skills, general statistics, and I always call it scientific common sense. Can you solve a problem? Can you just, hey, let's think about how we can solve that problem, just like a little kid, basically. That helps. Another thing that you hear a lot is some XX will solve our problems. That's the one extreme. The other extreme is XX will never work. And you can say AI, you can say neural networks, and I've heard all these things, right? So neither extreme is true. I would say the truth is somewhere in the middle. Learning from data definitely helps in finance. Lots of people know that, but it's still, I keep saying it every day, and there's still people who, it takes a while to understand that. It's not a black box that will solve every problem we have, right? There are some useful aspects, but ideal solutions take a very long time, and humans, for now, are clearly needed in the loop, and I think this will continue for a long, long time. Because some people are scared that it's just going to be machines, but I don't think so. So finally, the last thing is this is what I hear also from candidates. We talk to a lot of smart candidates, and they have all seen Wolf of Wall Street, and of course they know it's not exactly like Wolf of Wall Street, right? But still, there's something often stuck in their heads that they say, maybe a little bit like it, right? And I go like, no, it's not like that. It's the research is similar to a big tech company. You sit at a computer, you program, you have meetings, you talk to your colleagues, you work at a problem. And what is the by far the most important indicator of happiness in research is interest in the science of the problems and nothing else. Not the money or something like that, right? You really need to be interested in okay, let's make reinforcement learning work for this problem, and things are actually going to be much better, right? So that's, I think, is the most important thing. The other thing, trust, honesty, integrity are really, really very important in finance because IP is such a sensitive issue. They want to trust you. We want to trust the employees. And if you don't think you can somehow get around that, you will have a lot of problems. And this is, very different from the Wolf of Wall Street, maybe, right? So finally, research in quantitative investment is, and that's what we are doing, is, just as a summary, is overall quite similar to tech research. It's, research-driven with lots of PhDs, academic collaborations with universities like MIT and Stanford and Harvard and whatnot, with professors. We go to conferences. We have fewer external publications. There are really interesting cutting-edge problems to solve, like for deep learning, reinforcement learning, and any kind of machine learning. And actually, we are having a lot of fun I think. So anyway, we fit this exactly into 20 minutes. Nice. Thank you. We would have a Q&A, but come to me later and ask.